what I'm going to do in this talk is to try and give you a kind of a sense of how to think about different things in in society and the economy. It's trying to introduce you to the idea of thinking about those things using the notion of a network. Okay. So let me start by saying that a network is a very, very simple object. It's essentially a set of dots or nodes and a set of links connecting these nodes. Okay, and so that's the, if you like, the mathematical object. And what I would like you, as Pushkar was saying, everything is interconnected. Well, so in some sense, when you think about some phenomenon or something happening, you start thinking about, how it's connected to other things which may have caused it, or how it is connected to other things which will be impacted by it. And so that's very naturally suggestive of the metaphor, if you like, of a network. Okay, and what we have been doing, I along with many other people over the last 30 years, we have been studying many questions in economics and in using the idea of networks. And I want to give you a very, very short introduction to some of the ideas, some of the sort of key concepts and some ideas that we have developed. And so that's what I'm going to do in the next 35, 40 minutes. And we will then have some discussions. And I would also like you to think about current contemporary developments, and we're going to come back towards the end of the talk on some major developments that I think it's very useful to think about them in terms of networks. Okay, so this is going to be a fairly high-level talk in the sense that I will be, presenting some pictures and just walking you through. So this is the cover of my book. I don't know whether the college has a copy of this book, but you should be able to get online copies of this book. And who knows, maybe there is a pirated version floating around on the internet. I would urge you, it's targeted at advanced undergraduates at top educational institutions. So I fully expect, Hindu College third-year students to be able to enjoy reading the book. So let me actually give you some leading examples of institutions or systems which are naturally, very naturally, one can think of them as networks. So if you think about, let's take finance. So think about banks. So we deposit our money in a bank, and then the bank then lends money often to projects, but more equally often it lends money to other banks who may be needing cash. Those banks might in fact then invest, or they may invest in some projects, or they may put money in some financial institutions. So you see now that there is a link between me to my bank, between my bank to some project, between my bank to other banks, and that is a network. Okay, and now one might ask, what is the structure of this network? Is it the case that it has some very striking structure? One might ask whether the structure matters. What do I mean by that? Supposing, a bank invests in some project, the project goes wrong, the bank is in trouble, the bank goes insolvent. Well, other banks which have lent money to this bank, or I've deposited money in this bank, I'm going to lose this money, other banks are going to lose this money, and those banks might go under. And then it might spread. There may be a contagion, a financial contagion. Okay. And whether it will happen, it will not happen, it seems, depends a bit on the connections between these banks. Okay, and you may wonder when the government should step in, or should the government step in, to prevent this contagion from spreading and taking over the entire financial system. Okay, so of course this financial network is created by banks and institutions borrowing and lending from each other. So you see that this network itself is created by entities. And so we want to understand what are the motivations that lead these entities to create the networks that you see around. Are these networks robust? Are they going to be very open to contagion? Are they going to resist contagion? And so on. Okay. So those kinds of questions arise and really and all these applications. I've given you example of finance, but you could think of production networks, you could think of infrastructure networks, and I will talk about these networks in this lecture. You probably, most of you are day scholars, so you come from home to the college. When you do so, you probably take the bus or you take the metro, and that itself is a infrastructure network. Okay, and one can move from those sorts of networks to social networks. So these are, you may have friends who have friends and who have friends, and that set of nodes that yourself and the friendships that are links create a social network. Okay, many of us are a key question if you're a student is, how well do you do in exams? And a question maybe a hypothesis may be that perhaps you do well if your friends are also hardworking. It helps. And so it seems as a social network is going to have an impact on what you do with your time, what your values are, which exams you take, which occupations you follow. And so those set of questions naturally have to do with how networks impact behavior. But of course, equally interestingly, we may wonder who becomes friends with whom, and it may be that most of the time female students are friends with other female students and male students are friends with other male students. That's a very common feature, and that suggests that if you pick an average male student, if half the students are female, most of his friends are likely to be male. So in some sense, these networks are not, if you like, random, but they exhibit properties like homophily. You form friendships with people like yourself. Okay. And that's going to matter because maybe you're going to do what your friends do. And if they're all like yourself, then maybe there may be, segregation and very different ideas and very different practices in different parts of the network, which may or may not be a good thing. Okay, so those kinds of things relate intimately to networks, and we therefore want to understand what network structures exist, why are they having the structure, and what are the implications. So here are the themes of, that I should say that it's not just economists, but also many other disciplines like computer science, mathematics, and sociologists, political scientists. They all actually are using network ideas to study questions. Okay, so, but what are the fundamental questions? What are the origins of networks? What is the empirical structure of the networks? And what are the implications of these networks? I'm sorry. And one other question that comes up naturally, as in the financial networks example, is supposing you are a government and you see there are some banks that have collapsed, you can now use your knowledge of the network to intervene in an efficient way rather than, intervene in a random way to the banking system. You can ask yourself, if you know a lot about the network, perhaps you can economize and intervene in a targeted way at a few points of the network to control the contagion. Okay, so but of course you can ask this question in many different ways. You could ask this question. Uh, uh, it doesn't necessarily have to be the government. It could be some criminal organization which wants to, let's say it wants to disrupt, the functioning of a computer network or an infrastructure network. And then it might want to use the knowledge of the network to intervene in an effective way, okay, to disrupt the network maximally, which in turn, if you think ahead, would mean that you want to create the network in such a way that even if it's attacked, it would be robust. Okay, so those kinds of questions arise very naturally once you start thinking about these things. Okay, so I'm going to give you, so I won't talk a great deal about the book, but this is also a sort of a way of organizing one's thoughts. So let me give you some examples about that will make things a little more concrete. Okay, so this is the US production network. And what is this? This is, if you look at it, this is a network which has nodes and it has links. And each sector is a node, and a link between from one sector to another indicates whether you are selling from one sector to another or you're buying from one sector to another. So in other words, this is an input-output network. Okay, and what you see here is that there are about, I think there are about 400 sectors, but you see that this network, if you read the slide, is very sparse. By that I mean most of the potential connections are actually missing. So only 2.5% of the potential connections between the sectors are actually present. In other words, it's a very sparse graph. Okay, it's very unequal. For you take a sector at random, what is the average number of incoming links? 7. Okay, but there are sectors which have 100 incoming links. So it's a very, very unequal world, and indeed those bright red spots are the hubs. Okay, and they are the hubs in the sense they are central to the functioning of the US economy. Okay. The other feature of this network is that the distance between the different nodes, even though it's a very large network and it's a very sparse network, the number of loops it takes to go from one sector to another is very, very short. Okay, so imagine if you put 400 sectors, for instance, on a line. Well, then the average distance will be something of the order of 100. But here, the average distance is only of the order of 4. Okay, so in other words, most sectors are very close to most other sectors, and in fact, they are connected through these hub sectors. Okay, so this straight away suggests a number of hypotheses. Since these sectors are so salient, if something goes wrong somewhere in the economy, sooner or later, very soon, it's going to impact the hub, and from the hub, it will impact many other sectors. Okay, and so maybe this is a very different network compared to a network which is really, really spread out, right? So when something happens in one sector, it takes a very long time for it to percolate through to the other sectors. The US production economy is not at all like that. Everything is rather close to everything else. Okay, so just to drive the point home, it's not just true of the US economy. Indeed, if you take the Chinese economy or the German economy or the Indian economy, you have very similar features. There are these hub sectors, and the networks are highly centralized. Okay, of course, the hub sectors are going to be different in India as compared to US or Germany because the stage of development of these economies is different. Okay, but the high-level topological structure of the graph or the network is rather similar. Okay, so we'll come back to that, but you can see that that kind of structure is going to have a number of, it poses a question, why is it that it is like this? What implications does it have for business cycles, for economic fluctuations? And what does it imply for effective government intervention? Okay, so we're going to come back to that in the Q&A. Let me now turn to something that's very much in the news. You must have, if you are reading the newspapers, you must have heard the word decoupling, right? And this has been very much in the news, at least for a few years. And with the election of Trump, it's become even more salient. But the idea is that somehow with Brexit in the UK, decoupling is an attempt, a deliberate attempt to delete, to weaken the link between myself and someone else. Okay, so my country and another country. So Brexit was an attempt to weaken the links between the UK and Europe, to cut down the immigration flows, to cut down the flow of capital, and so on. And similarly, the US is, under Trump, is trying very hard to, to try and cut down its links with China, and also, interestingly, to encourage many other people to cut off their links with China. Okay, so it's trying to, so we want to think about, so I would like you to think about those things, and with those things in the background, okay, I want us to think about why might that be, or why might that be a possible way of moving, doing things. And so I'm going to think about a world of intermediation. Okay, I'm going to think about a world of brokerage. And I want us to think about two kinds of situations. There is a dominant hub like Amazon. It's the dominant hub in retail. Lots and lots of millions of buyers are linked to Amazon, people like you and me. And there are millions of sellers, suppliers, firms linked to Amazon, and they have, but then if you look at financial intermediation, in fact, there are many banks, and it's not the case that, you have a single hub and everyone's connected to this hub. Similarly, if you think of tea or coffee supply chains, it's not a single hub, it's more complicated. Okay, so we want to think a little bit about what are the determinants and what kinds of structures can arise. Okay, and so I'm going to give you, I'm going to walk you through an experiment that I and some of my co-authors ran. This is a very recent paper which just was published last year. And what I want us to do is to think about, if you and I are trading and directly, we can split the surplus. But if you and I are trading through Pushkar, then maybe Pushkar will get a cut. If we are trading through long chains, then all the people who are on this chain might get a small cut. And so we want to think about brokerage rents. We want to think about people creating networks, firms creating networks with a view to trading, but to economize on the cost of linking, they may just link with one hub and then trade with lots of people via this hub. This is what you and I do when we trade through Amazon. Okay, rather than going to the shop and buying each of these things from different shops, we just go to Amazon and buy everything we want from Amazon. Okay, so we want to understand, when will you have an Amazon-like outcome, and when are you going to have these long chains of intermediation that's characteristic of financial institutions. Okay, so I'm going to focus a bit on pricing rules, but without getting into a lot of details. Basically, I'm going to look at two extreme pricing rules. One where the two traders are going to pay some intermediation rents only if the intermediary is a monopolist. In other words, if I and Pushkar are wanting to trade and there is a cycle of intermediaries, we're going to only pay them if there is no other cycle that we can go through. Okay, so this is a video which is taken from our experiment. There are 100 subjects here, and we're going to run a dynamic this takes place in continuous time, in real time, and we want to understand what's the network that arises. And you will see in a moment that with this process of pricing, you're going to get very long paths. Okay, so this is the dynamics. So these are people proposing links. Links are arising, the network is evolving, and this is over 6 minutes. And you see that there are some more connected, others less connected, but you see also it's very sparse. The number of links is 150, which is 1.5 links per person. There are 100 nodes, so you could be forming 100 links per person, but you're only forming 1.5. So it's very sparse. Okay, and it's evolving, and it's still very sparse, and there is no clear hub, and there are potentially long paths, and this is how it is, and this is how it's going to remain actually as we go along. There is no super connected hub in this outcome. Okay, so this is, by the way, with human subjects in a laboratory, and it's you can see it's based on real data from the lab. This is what human beings are doing, creating these experimental networks. And let me draw your attention to top left. You can see efficiency, which means that it attains roughly 80% of all possible surplus. It's not very unequal. The highest payoff versus the lowest payoff is just 3 times. And it's very sparse. It's got 140 links. And you can see it's, relative to the number of, that is 1.4 links, per person. There are 100 people to link with, so it's really sparse. Okay, so next I'm going to turn to a different pricing protocol. Let me stop this here. Okay, this is a pricing protocol in which if Pushkar and I have links through many people, we will only trade through the shortest path, okay, on the network. If we have links through Shubhangi and there are other paths which are longer, we will only trade through Shubhangi, and therefore she will get a cut, but nobody else is going to get a cut. Okay, so this pricing system places a premium on being on the shortest path. Okay, and we'll see it's going to make a fundamental difference to the dynamics of linking, and the architecture of the network and the inequality that's going to come about. So keep your eye on the red node. Okay, she's a key player. She's got lots of links. You see the efficiency is very low. The inequality is really large. If you look at the top left corner, it's 15. And the red node, is still going strong. And so as we go along, if you keep your eye on the top left corner, you will see the efficiency is about 60%. Inequality is really, really high. The hub is earning 35 times the average. So it's a very, very unequal network. Remember, in the other setting, the inequality was about 3. Okay, and it's a very sparse graph again. So you see that the pricing system, how much the broker earns and who earns, is decisive in shaping the architecture of the network and the inequality in the network. Okay, so that should give you a feel. Now we're going to come back to this, the setting when we, at the end, if there are questions on decoupling. Okay, we'll come back to this issue. Okay. Okay. So Pushkar, how am I doing for time?
So we are going smoothly. There's no issues with the time.
Okay.
Okay. So a bit longer as well if required. Not an issue.
Okay. So I'm going to talk a bit about infrastructure networks next, and they are everywhere. Okay, I've mentioned a few, but airlines, trains, roads, pipelines, airlines, sorry, it's repeated, shipping, canals, internet, and we use them all the time. I haven't mentioned electricity transmission. That's clearly a network, and I've not mentioned the World Wide Web, which is also a network. So. Um, what I want us to do is to think about the underlying motivations and the underlying economics of these airline structures, okay, of these infrastructure networks. So here's to get you thinking about this. Here I put up the airline networks of two airlines. These are both UK-based airlines, but you can take your favorite airline. Maybe you want to take Indigo or some other airline that you like, maybe Singapore Airlines or Air India, and you can do the same exercise. So on the left, I have British Airways, and I don't know how easy it is to see this, but if you stare at it for a bit, you will see that it's a very simple hub-spoke structure. The hub is London, and essentially, if you want to fly from any place in the world to any other place, you have to first fly to London, and then from London you can go. So, for instance, if you want to go by British Airways from Delhi to Mumbai, how are you going to do it? Well, you're going to go from Delhi to London and from London to Mumbai. Okay. Similarly, if you want to go from Delhi, let's say, to Paris, well, you will fly from Delhi to London and from London to Paris. On the right, you have Ryanair, and if it's hard to make out because it's very dense, but what happens in Ryanair is if you want to fly, let's say, from Paris, let's say, to Milan, you might be able to fly directly. You don't have to come to London. Okay. In fact, most of these city pairs have a direct link. So really, there are two very different kinds of networks here, both operated by profit-making companies, profit-seeking companies, British Airways and Ryanair. Okay, and on the left you have a hub-spoke structure, and on the right you have a very dense network, which is close to what is known as a point-to-point network. Okay, so the question you should ask yourself is why is it that British Airways runs this hub-spoke network and Ryanair runs this point-to-point network? Okay. Why, what are the reasons? What are after all, these are profit-making companies, and so they must be doing it because it's a smart thing to do as an airline to operate these networks in this way. Okay. So at a high level, the idea is quite straightforward. If links are very costly, you will have few links. And if links are cheap, you will have many links. Because ultimately, it's passengers going from point A to point B. And if links are cheap, well, you will connect A to B. But if links are costly, you will take A to some hub, and from the hub, you will go to B. Okay. And so that's sort of the basic intuition. And indeed, if you fly British Airways and if you fly Ryanair, you will see that British Airways normally has much larger airlines, which are much more costly to run, and Ryanair has much smaller airlines. In fact, it has one particular aircraft for almost all its operations, which is roughly about 100 odd passengers that it flies. Okay, it's the same plane, and it's much cheaper to operate, and and so you can. So that's sort of the very simple economic intuition why you might go from point to a hub-spoke structure. Okay, I want now move to another infrastructure network. Okay, and we will see that this is a much more complicated example. So this is the train network. Okay, this is all material, by the way, from my book. So as you're aware, trains in India started in the 1850s, and the first train line goes back somewhere, in Chennai or Madras, which didn't really work out. And the one that's operational was between Thane and Bombay. And from that starting point, bit by bit, but within 40 years, you have a pretty dense network. When you start, you connect Lahore to Delhi, to Calcutta, to Mumbai, to Chennai, but then you fill it in. And on 1890, you see these trunk lines, and then it gets denser. And if you look a bit more closely, you see that the network is denser in the northern plains, and that's partly because of population, but it's partly also because they are plains and you can lay down the rail tracks, whereas in the Deccan and elsewhere, it's harder to lay down train tracks. Okay. And of course, a major motivation for the train network was moving troops around the country. And so that's also a factor. You might want to ask yourself, what are the considerations that go into laying down the train network? And that's what's going to help you understand, what the structure is going to be. So here's another well-known train network, and this is the American train network, which also started roughly in the 1850s. And it was almost entirely driven by profit-making companies, unlike the British India railway system, which was entirely done by the British government in operating in India. Okay, and so strategic factors were probably much more important, the military, etc. Whereas in the US, it was essentially profit-making companies which was running it, and there was no military strategic factor, if you like, at work. Okay, so you see that it's spreading bit by bit from the 1870s to, it should not be 1990, by the way, this should be 1910. But you see that, again, it gets denser and denser, and the density is related to population density, and it's related to the terrain and so on. But you may want to look more closely at competing train companies and how that mattered, and so on. Okay, and of course I haven't mentioned this here, but railroads, as they are called in America, or trains in India, are competing for traffic with roads, at this time, and with river canal transport. Okay, so there's a lot of interest in understanding how these different infrastructure networks complement and substitute for each other. Okay, and so I will leave it at that, and I will now turn to social networks. And social networks matter for a number of reasons. I've mentioned some on the slide. So clearly social networks, as I think all of you probably will agree, all of you probably have digital network presence, and maybe it's Facebook, maybe it's Instagram, and you're sharing, or WhatsApp, you're sharing information, and that affects your opinions, your learning, and it affects probably your choices. It might affect your values, your norms. And so information networks are, social networks have very serious implications, very serious, potentially very powerful effects on information. Of course, as you will recall, all of you will probably recall the difficult days of COVID epidemics, and there you will recall how attempts were made to essentially make the network of contact between people was viewed as a major route through which COVID would spread. So governments all over the world tried to restrict contacts. In other words, they tried to fragment the network as much as possible to contain the spread of the disease. Okay, so again, in that epidemiological context, the social network of contact is important, and indeed, when there is an infectious disease, where should the government intervene? Is a key factor. And indeed, as you may remember, in India, there were these different religious fairs at the time of COVID, and people were alarmed that there would be super spreader events. Okay, and so in other words, the network was made denser through thousands and hundreds of thousands of people aggregating at different religious sites, and that was going to greatly increase the risk of infection. But essentially, the super spreader events, you can think of them as ways in which you change the density of the network. Okay, so I'm now going to talk a little bit about social networks. Okay, and I'm going to walk you through a couple of very interesting features of social networks. Okay, so these are examples. On the left, I have data from an Indian village in Karnataka, and these are favor exchange. So think of it as households in a village, and there are about I don't remember, maybe a few hundred households, and they are exchanging favors, like maybe exchanging kerosene, exchanging rice, or exchanging small sums of money, and that's the link. Okay, and what I've done here is to indicate a key property of this, which is that I've colored the different castes in this village. And what you see here is that most of the links are within a caste. So the green caste, the yellow caste, the blue caste, they are the dominant caste, the yellow and the green. And most of the favor exchange is happening within the caste, and rather few favor exchanges are happening across the caste. Okay. On the right, I've given you a network which is taken from an American high school. This is a friendship network, and the greens are the green color are Black students, African American students. The white race, white Americans are in yellow, and all the mixed race are in red. And what you see here is very striking. You see that the greens are all clustered together, and there are two clusters of greens reflecting two different class years, year 5 or year 6, something like that. And there are very few ties between the 2 years, but interestingly also there are very few ties within the same year across the two races. Okay, and the reds are mixed up. So the reds are the mixed race children or pupils. Okay, so what we see here in these two different settings is a very dramatic illustration of the idea that likes attract. Birds of the same feather flock together. Okay. Now we can start asking questions about why would this matter? The fact that people of the same race hang out together or people of the same caste hang out together. Why would it matter? Okay. And does it matter? Would it lead to serious sort of, outcomes that we'd be interested in? Okay. But I just wanted to flag that network topology and its this idea of likes attract each other. Another feature of social networks, very, very striking, very startling, I would say, is that if you go back to Twitter, now known as X, this is a data from, I think, about 10 years ago. And this particular empirical study covers 320 million users. What you see here is the top 10%, the top 10% of the users sent out, let me just be, had incoming degrees, so they were being followed by about 400 people each, and they sent out 80% of all tweets in the month, and they sent out about 140 tweets per month. By contrast, the bottom 90% of the users, their median number of followers was 20. Okay, and they sent out barely 2 tweets per month. Okay, so you see this is a social network which is created by people following each other, is profoundly unequal. And indeed, as you are aware, there are people with millions of followers, like Trump, or Obama or Modi, right? Most of us, if you are on Twitter, will have very few followers. Okay. So the first property I mentioned was homophily, if you like. Likes attract each other. The second property is inequality. Profound, startling, extraordinary inequality in these social networks. Okay. Most people have almost no connections, and a very small fraction have millions of connections. Okay. We want to ask, what does it imply for the spread of information? What does it imply for opinion formation? What does it imply for the motivations people have for creating links in this network? Okay. You will remember that the production network, the US production network, or the Indian production network were also profoundly unequal. So we may want to ask, are there general principles that govern, the creation of these incredibly unequal networks? Okay, so I want to give you a taste. This is going to be another experiment that I've run with some collaborators, Fred Mosson and Singju Choi. And I want to give you, this is a setting where I want to link with others to get information, but it's costly to link with others. So I'd rather link with others who also have many other links, because then I can indirectly access lots of information. Okay, so I want to run through this dynamic model of linking and see what happens. And you will see that, so on the top left, I have social efficiency in degree centrality, how centralized is it, how many hubs there are. Okay, and you will see that the dynamics are very unequivocal. Okay, very, very clear cut what happens here. So these are directed graphs. It's a bit like Twitter. Who do I follow? The person I follow, I get their information and the information of the people they follow. Okay, so you see here, there is this red node, and it has formed some links, surprisingly. And then there are people who are forming links with the red node. And you will see that the red links going out from the red node will gradually be replaced by blue links formed by the blue nodes coming into the red node. Okay, so here it is. So what happened here is, this is the picture of very efficient network. 80% of all possible value has been realized. Almost everyone is either linked directly or indirectly to misread. And so it's very highly centralized, okay, and it's very efficient, and it's very close to a hub-spoke network. It's very unequal. Most people have almost no incoming links, and there is this person who has, 70% of the nodes are linking with her. Okay, so this is a simple illustration of how a desire to access information at least cost leads to the creation of these profoundly unequal, highly centralized networks. Okay. Okay, so I'm sort of trying to wind down, and I want to talk about trust. Okay, and then I will wind down. So a big idea that many scientists and have uncovered is the idea that if you ask people how much do they trust each other, simple question like how much do you trust a person, a stranger, or how much do you trust a person, on average, that question yields very different answers in different countries. So if you, after my talk, you can go and check world value surveys data, you will see that in some countries, 70% of the subjects think that you can trust people on average. in countries like Norway or Sweden and so on. On the other hand, in some countries like Brazil, the answer is only 5%, 6% of the people say you can trust others. Okay. So Joseph Hendrick and other folks, cultural anthropologists, have come up with this word, WEIRD acronym, which stands for Western Educated, Industrialized, Rich, Democratic. And these are societies like Norway, Sweden, UK, etc., which have very high trust. These are typically societies which have nuclear families, small nuclear families as the basic social unit. And these families have many links which are dispersed with many other similar nuclear families. Okay, many of them are weak links in the sense that you don't do a lot of things with any of these folks, but you do many things across different relationships. By contrast, you have non-weird societies. In fact, most of the world's population lives in non-weird societies. These are low-trust societies. You can take, for example, India, or you can take, we were talking about Brazil. These societies have familial ties. So it could be extended families, it could be clans, castes, tribes. And these societies are organized at a high level. But there are many strong ties within the extended family or within the subcaste or within the clan. There are very strong ties, and there are relatively few ties across these social groups. Okay, so this is how it's going to look like. A weird society on the left. These are I have two societies, one which has nuclear families, which are these yellow dots, nodes, and they have two links each in this circle network. And on the right, I have these nuclear families embedded in groups of 4. So these are, if you think of them as extended family groups, or you can think of them as a clan. And these groups have just one tie across, with 2 ties across with other groups. Okay. So within the group, the ties are very strong. I should probably have put very, thick ties within the group, but there are so this is this is an example of what a weird society sort of looks like versus what a non-weird society looks like. Okay, so what we want to do is we want to ask the same questions, right? Why is it? What does it? So a lot of researchers have said that the structure, social structure, leads to high or low trust. Okay, so that's an outcome we care about, because if you have high trust, you can do many things without writing contracts. You can just trust people, you can get on with your life. If you have low trust, well, you have to be so careful all the time. You have to find people you can trust, which will be people within your group. So it matters whether you have a high trust or a low trust society. And the argument is that the social network affects the trust level. That raises in turn the question, why is the social network the way it is in weird versus non-weird societies, okay, which is the origins of networks. So here's another almost a final picture of what happens when you think about collaboration networks. So this is, of course, a very stylized picture. This, on the other hand, is taken from the data. This is the data. Daron Acemoglu won the Nobel Prize this year in economics, as some of you might know. He's probably the leading, one of, if not the leading economist in the world. But here is his network. This is the network of people he has written papers with in the decade 2000 to 2009. So he's sitting in the middle. You can see him, Acemoglu is blue, and his co-authors are in yellow. Okay, so his most prominent co-author is James Robinson and Johnson, who both won the Nobel Prize with him. And you can see there are very thick lines, links between Daron and Jim Robinson and Johnson, right? But these people in turn are linked with some other people with very thick ties. You can think of them as strong ties, but most of the ties in this picture are weak ties, in the sense these people have collaborated maybe on one paper. Okay, so what I want us to think about is, how does trust arise, in these type of societies? How does it flow through strong ties and weak ties? And let me leave you with this picture. Maybe this is also a network if you think about firms, or if you think about powerful people in society, maybe powerful celebrities, maybe they have a similar type of network. And so I'm going to leave you with questions about why is the network having this feature? Why does it have this structure? What are its implications? Okay. And let me just close on bringing back this whole issue of decoupling and just show you. I think I'm out of time. Show you the cover of my book, and I'm going to close and I'm happy to take questions.